Section 2.2 is on systems of equations. There'll be 3 equations and 3 variables. And we'll also introduce matrix representation of a linear system. Alright, so a little recap. We've done the elimination method before, but before we extend it to 3 variables, let's go over the 2 variable ones. The elimination method here. If I, remember you try to match the coefficients but be opposites. So if I take this first equation, multiply, it's multiplied by a -2. -2, then watch what will happen. I'll have a -2x plus 8y equal to 0. Then if I recopy the second equation, then those 2 coefficients, they match with their opposites, so when you add straight down, those cancel. That's what should happen. You add straight down, the x terms cancel. I'll have 14y equals 14, so solving for y, you'll get y equals 1. And to get x, plug it back into either one of those equations, so x is going to equal 4. You really should write it as an ordered pair. Make sure your x comes first and then your y. So 4, 1. So now, let's expand it to, let's look at that 3 by 3 system with elimination. Now, you're not going to do this very often. You might have 1 or 2 to do in the homework. Hopefully I didn't give you too many more than that, because these can get a little tedious. Again, not difficult, but sometimes they can be a little tedious. And what you do with the 3 equations, you see I have 3 of them here, and I have x, y's, and z's. So what I'm looking for is one particular, it's an ordered triple instead of just an ordered pair. It's an ordered triple, an x, y, and a z that satisfies all 3 of those. Alright, so what you try to do is you're just going to boil this down to a 2 by 2. You're going to pick sort of a control equation, and mine's going to be that first one. And what you're going to do is try to eliminate one variable out of the other 2, so it'll take it down to a 2 by 2 system. So what I am choosing to do is to eliminate. Using this first equation as my sort of control equation, I'm going to eliminate the x's out of equations 2 and 3. Right, this is equation 1, this is equation 2, and this is equation 3. So, just looking at this equation 1, if I want to eliminate this 4x, what I'm going to do is multiply my first equation times a -4. Alright, that's -4 times equation 1. Watch what I get. I'll get a -4x minus 4y minus 4z is equal to a -8. Alright, I'll get that. Then, if I put equation 2 right underneath it, watch what happens when I add those 2 together. My x terms go away, that's what I wanted. I'll have a -y, that's a -2z, is equal to -12. Alright, we're going to hang on to this one. Let's highlight this one. Alright, that's in blue. Notice I don't have any x's in there anymore, so I'm trying to eliminate those x's. I eliminated this one, now I want to eliminate in equation 3, I want to eliminate this x. So that means if I take 2 times equation 1, let's write that down, 2x plus 2y plus 2z equals 4, then let's rewrite equation 3 over here, -2x plus y minus z, that equals 2. Alright, so then doing that, you eliminate those x's. I'll have 3y plus z equals 6. Let's highlight this one in blue as well. Alright, so now you can see we have a 2 by 2 system. I've sort of boiled it down now to a 2x2 system, and I'm going to rewrite that so I can try to solve that. When I solve this 2x2, I'll have an answer for y and z. Then I'm going to back substitute to figure out what my x is. Alright, here's my 2x2 system. It's negative y minus the 2z equals negative 12, and then I'll have 3y plus z equals 6. Alright, that's my 2x2 system there. So, if let's rewrite the first one here, because what I'm going to do, I'm going to eliminate my z's, multiply that second one by 2. Alright, let's rewrite this. Minus 2z is equal to negative 12. Yeah, let's take that second equation, and I'm going to multiply by 2. Alright, times 2, so this is what I'll get. I get 6y plus 2z is equal to 12. Good. Alright, so look, my z terms go away, and I end up with 5y equals 0. Put a 0 over there, that's okay. Which means y equals 0. Alright, I've got y equals 0. That's one part. If my y equals 0, I'm going to plug that in there to find my z. Which means z equals 6. So I've got an answer for y, I've got an answer for z. Watch what I do with those. Z is 6, y is 0. I'm going to plug those in there. Way back up into the very, very first equation, and we'll figure out what x is. Alright, so that means I've got x plus the y was 0 plus my z is 6 is all equal to 2. So that means x equals a negative 4. Alright, all this is your answer. You've got an answer for x, y, and z, and the way you write it with an order triple, the x comes first, then the y, and then the z. Alright, let me back up and recap these steps of what we did and how you should approach these problems. What you need to do is look at your original system that's given. Pick one of those variables that has a 1 coefficient, so you can easily eliminate that from those other two equations. Alright, I chose to eliminate my x's, so I'm picking this first one for my control equation. And then I eliminated the x from the second equation, that's what I did over here. And then I eliminated the x term from the third equation, I did that down here. Once you do that, if you eliminate the x's, you come up with these two equations then with the two unknowns, y's and z's. So that was my 2x2 system over here. You already know how to solve a 2x2 system, so when you solve that, you'll get answers for y and z. Then you can back substitute. I always back substitute into that control equation that I started with. Alright, to find that third value. Okay, that's a 3x3 system. Here, to do it by elimination, it's a little tedious. We're going to learn a little bit later how to do it with matrices, or matrix, with the matrix notation. Alright, so let's talk about matrix notation here. First thing we're going to talk about is a coefficient matrix. And a coefficient matrix is exactly what you would think it is. You know, a matrix is just like an array of numbers. But if you have a system, and we're talking about a coefficient matrix, what it's going to be is a matrix made up of all those coefficients of the system. Alright, all you do is pull off the coefficients as it says right there. So, let's look at this example. Write the coefficient matrix for the following system. This is a big 3x3 system, 3 equations, 3 variables. So, to write the coefficient matrix, what I'm going to do, we're not going to deal with the right-hand side, not for now. The coefficient of x in the first one is 1. Coefficient of y is negative 2. Coefficient of z is 3. Do the same thing across the second row for that second equation too. If your y term is gone, that coefficient is 0. Negative 1 for z. And then for that third equation, that negative 5, 10, and a 7. this is your coefficient matrix. Right? It's pretty straightforward. Students do really, really well with that. It's very logical. Now, an augmented matrix, we have to go through some terminology. So the augmented matrix then is going to be your coefficient matrix, including the right-hand side of the equations. Right now we're going to include the 6, the negative 11, and the negative 5, but watch what it looks like. So your augmented matrix, you start with the coefficients. Oh, we're using this exact same one back here. It says use the same system above to write the augmented matrix this time. So start with your coefficient matrix. Then here's the augmented part. You put a straight vertical line after your coefficient matrix, and then you write the right-hand sides. You can think of that straight line right there as like an equal sign. Okay, this first row of that augmented matrix represents the first equation. This is x minus 2y plus 3z. Here's my equal sign, 6. Right, that's how you read those off. So you should be able to, if they give you a system, first of all, can you write the coefficient matrix? Everyone does that well. Augmented matrix, make sure you put the line here, and then put those right-hand sides over there. But also, make sure you can go the other way. If they give you the augmented matrix, can you write out what that system is? Right, so you're going to practice that in WebAssign. Let's go over, I'm keeping an eye on the time. Let's go over this notation for the positions in a matrix, and then I'll do the examples in the next video. Alright, positions in a matrix. Each one of these numbers has a certain position associated with it, and the notation you use is like A11. The first number of that subscript is the row, the second number is the column, so it's sort of A, sub row, and then the column number. It's written as a subscript like those, or you can do it sort of like an ordered pair. Let me write this a little bigger. A, first the row, and then the column. Alright, so for example, A23 would be the number that's in the second row, third column. Second row, third column. Yeah, right there is A23. Right, or you can also be written like this. 2, 3. Looks like an ordered pair. Actually write it like an ordered pair. But this is the position, the row, and then the column. Instead of using this notation, A23, the ordered pair 23 can also be used to represent this number in that position. Right, we'll do an example of this in the next video.